Okay, so here we have our perpendicular bisector theorem and its converse, which again told us the perpendicular bisector theorem says, suppose you have a point and it's on the perpendicular bisector. How do I know it's the perpendicular bisector? Well, it makes a right angle with AB and it cuts AB into two equal segments. If it's on that, then it is an equal distance from both A and B. So the distance from A to X would be the same as the distance from X to B, is what we find out. The converse goes in the opposite order from that. It says, suppose you have a point on a line that passes through this segment, and when it passes through, that point is an equal distance from the two endpoints. So it's an equal distance from A and from B. If that's the case, then you know it's on the perpendicular bisector. So you know this forms a right angle, and you know the line cuts that segment into two equal parts. So let's use that to solve this problem. Suppose segment DE is bisected by segment FG. So let's start with that. Let's just kind of sketch what's going on here. So I start with what they told me. They said, suppose segment DE. So let me draw a segment from D to E. Suppose that segment is bisected by segment FG, where F is the midpoint of DE. So F needs to be the midpoint, the point right in the center of DE. Okay, so here's my F, and it should go up to a point G. Okay, so far so good. We have our segment DE that is bisected by FG, and F is the midpoint for DE. Given that segment DE is 10.5, so from D to E is 10.5, DG is 13.6, and EG is 13.6. Draw those lines in. What can you say about the relationships of segments DE, the whole thing, and FG? What do we know? Well, let's use our theorems. What do we know right now? We know that we have a point G that's an equal distance from D and E, the ends points of our segment. Okay, what did the converse of the perpendicular bisector theorem tell us? It told us that if that's the case, then you know G is on the perpendicular bisector. So it tells us that FG would be perpendicular to DE. Not only does it cut it in half, it also must be perpendicular, and we found that using the converse of the perpendicular bisectors theorem. So if you want it in words, FG and DE are perpendicular.